So in our last video, we saw how we could combine this orange vector and the green vector and find their resultant by adding them together. And we found the red vector was its resultant. Using a ruler and a protractor, we found the magnitude, which was 9.7 centimeters. And using our scale, we found it to be 19.4 meters per second and 55 degrees using the protractor. But let's see if we could figure those numbers out using just math. So I redrew that same problem. And if we want to know the length of this resultant vector, the red vector, we can actually use all math without doing any measurement and find the length and also the angle of it. So how do we do that? Well, first, this problem gave us a nice hint that every 2 squares is 1 centimeter. Okay? Now that'd be great if we could kind of cut a piece of this paper out and use it as a ruler, but let's say we're not going to do that. We can also use some of our math rules and realize that if we make a right triangle using this red resultant vector, we can use the Pythagorean theorem to find the length of it. So let's do that. We can draw a vertical line down and a horizontal line. And now because we know every 2 squares is 1 centimeter, we can figure out exactly the length of these 2 purple lines. And this, now we have a whole triangle, and the red line is one of the sides of that triangle. So the height is 1, 2, 3, 4, 5, 6, 7, 8 centimeters tall. And 1, 2, 3, 4, 5.5 centimeters wide. So we can find the hypotenuse using Pythagorean theorem. A squared plus b squared equals c squared. And take out our calculator. We get 8 squared plus 5.5 squared. Okay, 94. And 25. And then we're going to take our square root of our last answer. And we get 9.7 equals C. Oops, equals C. Okay, and that's 9.7 centimeters. So if we take 9.7 centimeters, the problem also told us 1 centimeter equals 2 meters per second. So we're going to multiply that by 2. And we get 19.4 meters per second. There's our magnitude. And let's check how that worked out compared to what we measured before. Hey, it actually matched exactly. That's great. Sometimes they can be slightly off due to our measurements using our ruler, but looks like we got exactly the same numbers, which is great. Now, how do we find the angle? Well, the angle is always measured between our resultant and the x-axis, so we got to put that in. And this is the angle we want. The problem is we don't really have a triangle including that, but we know alternate interior angles are equal, so this is the same angle. So these are both theta. So we can use some trigonometry now, and because we have the 2 legs of this triangle, and this is the opposite side and this is the adjacent side, we can use tangent of theta equals opposite over adjacent. So tan theta equals 8 over 5.5. And we move that tangent across, and we get the inverse tangent of 8 divided by 5.5. And we, again, pull out our calculator. So we hit second tangent. And then we put 8 divided by 5.5 in there. And we get 55.5 degrees. So theta equals 55.5 degrees. And let's check. How does that match up to our measurement? Hey, you know what? 55.5. We measured it with a protractor as 55, and I'd say that's pretty close. So here's how we find our magnitude and angle using math.